Good morning, students. Today we are going to discuss a new topic from a chapter, Dual Nature of Radiation and Matter. It is under the chapter 11. Now the topic which we are going to discuss is your photoelectric effect. So all of you familiar what is photo? Photo means light. So photoelectric effect, let me read out what is there. It is the phenomenon of emission of electrons from the surface of a metal when the radiation of suitable frequency fall on it. So if you strike light on a metal surface, what happens? The energy of the light goes inside the metal surface and it takes the electron which resides in the topmost level and it absorbs the energy is absorbed by the electron, and if the energy is sufficient or if the energy of the incident light is sufficient or more than the work function of the specific metal, then the electron will comes out from the metal surface. So let me try to explain this topic by using this experimental setup. So you do have a chamber, and in the chamber you do have cathode C and anode A, and there is a window, and through the window light moves and it strikes on the cathode. Now when it strikes on the cathode, then light source definitely have certain amount of energy. So that energy strikes on the metal surface C. Now that energy when goes to the electron which resides in the topmost level, then that electron get excited, and if the incident energy is more than the work function or equal to the work function of the metal, then the electron comes out from inside the metal to the surface. Okay, now you see in the setup you do have a cathode, you do have an anode, you do have a commutator, you do have a potential divider, you do have a high tension source. Now you see the commutator part, these two knob basically, these two knob, this one and this one, you can slide it. So if you connect this one this end and if you connect this one this end, what happen basically, if you connect this one with this end, then negative, this one becomes negative, and this one is nothing but is your cathode. And when you connect this one here, what happen basically, this part is your positive. So what happen, you can increase or decrease the potential of cathode and anode by the use of potential divider. So what happen here, when the electron or when the light strikes on the metal surface, and definitely the energy of the light is more than the work function of the metal, then the electron comes out from the cathode, and that electrons get repelled by the cathode C because it is connected with the negative terminal as per the diagram, and anode is connected with the positive terminal. So what happens, the electron moves from cathode to anode. Now when the electron moves from cathode to anode, then we wish to get a current, and that current is nothing but is your photocurrent, and that can be measured by the microammeter. Now potential across cathode and anode can be adjusted by the potential divider, and the potential can be measured by the voltmeter. Now what happens basically, if the intensity of the incident light is more, then what happens, more amount of electron comes out from the cathode, and more amount of electron comes out from the cathode means more current. So we have constructed few factors with the graph and try to explain the parameter. Now you see that first term which we have to know, that is the work function, the minimum amount of energy required by an electron so that it just escape from the metal surface is called as work function of the metal. Now you see it is not possible for light whose energy is less than the work function of the metal which is available on the cathode, that photosensitive surface, or the metal which we specified as your cathode. So the energy of the incident light must be more than the work function of the cathode. So if it is there, then electron will comes out. Otherwise the electron will not comes out and you will not get the photocurrent. So the few terms, work function, this part is very important. Now next one is your effect of intensity. So if we increase the intensity of incident light, what happens basically, more number of electrons will comes out, and more number of electrons means more current. increase in the intensity only increases the number of electron. So this is your graph, effect of intensity, whatever we have written. The number of photoelectrons emitted per second is proportional to the incident intensity of the incident radiation. So more number of electrons will comes out if intensity will increases. Okay. Now more electron means more current. So this is your graph, straight line passing through the origin. Now the next part is your effect of potential. Potential is nothing but is your potential difference between C and A. If we make C as your more negative, what happens basically, the electrons get repelled by strong repulsive force, and that electron easily comes to the anode A, which is connected with the positive terminal. So as a result, there is an attraction and the current is there. So to get the photocurrent, what we have to do, we have to make C negative or lower potential and A is your higher potential, because electron is negative charge. Now if we increase the negative potential of cathode and increase the positive potential of anode, more electrons will get attracted. But if we decrease the potential of anode, and it means we are making lower potential for anode and higher potential for cathode, what happens? The less number of electron will move towards the anode, and if there is a possibility, if we make A is a more negative and C has more positive, then there may be the possibility that no electrons moves from cathode to anode. Okay, and that potential which we have given across C and A, due to which no movement of electron occurs, that is nothing but is your stopping potential. So to stop emission of electron, what we have to do, we have to make A negative and C positive. So you see in this figure, effect of potential. Now if we slowly increase the positive nature of anode A, and if we make the negative nature of cathode C, and if we increases this negative and positive nature, if we make more positive for A and more negative for C, so what happens basically, more repulsive force and more attractive force will be there, and as a result more number of electrons get attracted by the anode A, and as a result current slowly increases, and this potential can be varied by the potential divider. So it's not like that every time if you make A more positive and C more negative, every time you will get increase in current. So there is a specific potential for anode and for cathode, during which the current becomes saturated, means the constant amount of electron moves from cathode to anode, and that potential here we have shown, and that current we have shown, that is your saturation current, that is the straight part. And I1 and I2, these are intensity of light, and two graphs we have shown here, making two different intensity, but the same as the energy of the incident light. In both cases the source have same amount of energy as an incident radiation. So what happened basically, intensity I2 is more than I1, so more saturation current will be there for I2 than for I1. But the stopping potential is same, because we are not supposed to change the source, or we are not supposed to change the energy of the source of the incident radiation. We are keeping the energy same, but we are increasing the intensity, so we are getting more saturation current. But if we make C A as more negative than C, then what happen, no electrons will able to reach from C to A, and if no electron is there, it means no current. So that potential is known as stopping potential. So you are supposed to stop the electron to come from cathode to anode. So here we have written the maximum value of photoelectric current is known as saturation current. The minimum value of negative potential given to the anode with respect to the cathode, at which the photoelectric current becomes zero, is called as stopping potential. So sometimes it is asked, what is stopping potential? So under note you have written the maximum kinetic energy with which the photoelectrons are emitted is independent of the intensity of incident radiation, but depends on the radiation source. If the radiation source have more energy, then the energy of the photoelectron basically high. Okay, so energy of the photoelectron will be high if the energy of the incident radiation will be high. Now the next graph we are trying to define is your effect of frequency. So if we make the intensity same and if we change the frequency, you will see that frequency, if we nu1 is more than nu2, it means stopping potential for nu1 is more than nu2. It means if the energy will be high for the electron, then to stop it you have to give more negative potential for A. Okay, you have to make more lower potential for A compared to C. So A should be higher lower potential negative to stop the electron, and if the energy of the electron that comes out due to the energy of the incident light is more, then you have to give more negative. So that's why it is written here. You see, and nu1 greater than nu2. Nu1 and nu2 are the frequency of the incident light. So if nu1 is more than nu2, it means energy of the electron that comes out from the cathode is more, and to stop it you have to give more potential, which is negative potential obviously. So that's why V02 is greater than V01. So here we have written the value of stopping potential increases with the increase in frequency of the incident radiation. Now the next graph which we try to define here, stopping potential and frequency of incident radiation. So we have seen that there must be minimum frequency of the incident light below which there will be no photoelectric current, and that frequency is known as threshold frequency, because corresponding to that frequency the light has a specific energy, and that energy must be more than the work function of the specific metal which you have placed at C. Then a photoelectric current will be there. So here you see nu and nu dash, two different frequency at which the stopping potential is 0. The stopping potential is 0, it means no electron is coming out from the cathode. That's why you don't need any potential to stop the electron. If there is no electron coming out from the cathode, to whom you will stop? That's why you don't need to give stopping potential if no electron coming out from the cathode. No electron coming out from the cathode, it means the frequency of the incident light is less than the work function of the metal which you have placed at C. So that's why for metal A and metal B, threshold frequency for metal B is more. Threshold frequency for metal B is more compared to the metal A, because stopping potential is 0 at nu and at nu dash, means nu is not sufficient frequency to take the electron from the metal surface, and for metal B nu dash is not sufficient. So it means work function for metal B is more than work function for the metal A. So please go through this graph in exam. What happened basically, at least one graph is used to come during explanation part from this chapter, and this topic is very important, very important. Please go through and try to find out your doubts. This circuit diagram is very important. I think it's very easy to understand. Check it out once again. Experimental study. Once you know this circuit diagram, you can explain any topic. So two important parameter, one is your work function and another one is your threshold frequency. Okay, these two parameter is important. So please go through and try to find out your doubts. Thank you.